So I'm back. We are still factoring for those of you who have watched previous factoring videos. Now, this is a very interesting algebraic expression. There is a lot going on here. So first things first, let's identify how many terms we have. Remember, terms are separated by what? Good, addition and subtraction. So in the midst of all these parentheses, I'm seeing this addition sign right here. So I'm going to look to the left of it and see what operation I have. I see a multiplication operation, which means this is one term. Remember, they're separated by addition and subtraction. I've got 14 times that parenthesis. I don't care what's in the parenthesis. It's 14 times a parenthesis, and then I hit the addition sign, which means that's one term. Good? Look to the right of it. I see a parenthesis times another parenthesis times another parenthesis. All I see is multiplication to the right of the addition sign. So how many terms is that? Good, just one. Got it? Just one. Okay, so I technically only have two terms. So now that I've identified how many terms I have, remember the first step of factoring is to factor out or divide out anything that's in common. So let's look. I am noticing that both terms have this parenthesis of x squared plus 3x in common. So I am going to factor out the x squared plus 3x, and now I have to decide what power I'm factoring out. Am I only going to take one of those parentheses out? Am I going to take more than one out? Let's see. This one has 6 to give. This one only has 5 to give. Remember, when you factor, you want to take as many out as possible. So how many are you going to take out? Good, you're going to take 5 of them out. So when you take 5 of them out, let's see. We are writing what we're factoring out. And now, let's see what remains. I like to use brackets. They're the same as parentheses, remember. It's sometimes easier when there's a whole lot of parentheses going on. Okay, so out of the first term, I have one of these, I have the 14 and one of these x squared plus 3x remaining. And then I have the plus sign. And let's see out of this second term. Well, this completely goes away, right? And so I have the parenthesis of 84 plus 126 times 2x plus 3. Good? Okay. Now, there's a couple of different ways you can go from here. You can distribute and then collect like terms. Are you with me? Okay. I'm noticing this parenthesis, it's quite large. The numbers in there are quite large, which means since I'm factoring, I might see if I can factor something out of this. Okay? And to be honest with you, I'm hoping I can factor a 14 out, because that would mean I might be able to actually take 14 out of this entire bracket. So let's look. I have the original factor. I'm going to write it down. In the brackets, we still have 14 times the parenthesis of x squared plus 3x plus, now I'm going to factor 14 out of here, hopefully. Okay, so does 84 divide by 14 evenly? I know some of you got your calculators out. What'd you get? You got 6. Good. Hold that thought a moment. I knew I forgot something, guys. It's not your fault, it's mine. There should have been an x with this 84. That's okay. Just put a little rewrite in there. Good? Sorry about that. So I'm left with 6x. Good. Now I'm hoping that 14 also goes into 126. What do you got? I hear some of you saying 9. Okay, so let's see if that's 9. Yes, it is. Oh, but wait a minute. Huh. Well, we're going to leave it as is. Some of you might be noticing something. Some of you may not. It's okay. All right, question. I still have how many terms? 2. There's multiplication and there's multiplication. And now I'm noticing I can also factor out a 14. Well, this is going to make life a lot easier. So I'm going to factor out the 14 along with the original factor. Let's see what remains. I have just x squared plus 3x to the left of the addition sign, now to the right of it. We have 6x plus 9 and 2x plus 3. And so now it is time to distribute this parenthesis and then collect like terms, and let's see what we end up with. All right. I'm going to still keep this on the outside. And let's distribute. We still have x squared plus 3x. Gratefully, this is an addition sign, which means it's not going to change anything. I'm assuming you remember how to distribute, and if you don't remember it as well as you like, I suggest pausing the video, writing this out, and doing your own distribution, and then coming back and let's see if we agree. Good? Okay, so let's see. I have 12x squared plus 18x plus 18x plus 27. Okay, not too bad. I'm running out of board space. We better almost be done here. So, x squared plus 3x, the power of 5. Let's see what we have in the brackets. That's 13x squared, right? That takes care of this one and this one. So we have 3x and 18 and 18x. So what do you get? Good. I hear 39x. Excellent. Plus 27. Good. Well done. Nice, 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 nice. Okay. So, question is, are we done? And if you're like, I'm not sure, look at the brackets. I have a second degree polynomial. We have to see if we can factor it. There's nothing in common. Like 13 goes into 39 evenly, but it doesn't go into 27 evenly, so there's nothing I can do there. And now the question becomes, if I take 13 times the 27, remember, to make it from 3 to 4 terms, you would try to multiply these and then find 2 terms in the middle to replace the 39. Okay, but I'm going to do some side work over here just to see if this 13x squared plus 39x plus 27 is actually going to factor. Now, I have a little bit of a different method that I learned way back when. I don't recommend this. Why? Because it doesn't, it's a little more challenging to factor with, so don't worry about it. I know I'm going to have a couple of plus signs. So here's the deal. Let's see, 3 and 9. If that's 3 and that's 9, that's not going to work. If that's 3 and that's 9, that's a no. This isn't going to factor. This would be your final factored format for this particular algebraic expression. Okay, so recap. The original problem looks quite intimidating. However, if you first recognize how many terms you have, then it's easier to look at because you're looking at just a left side and a right side in this case, since there's only 2. And then I looked to see what they had in common and I factored it out. Good? Okay, so I have some examples coming your way. Work on them and then go find my answer key video and see if we agree. Have fun with them. Catch you on the flip side.